Afternoon, folks, and welcome into today's webinar, Resene Construction Systems, Plaster Coatings Inside Out. We're welcoming back Resene Construction Systems General Manager Mike Olds again today to present for us. Greetings, Mike.
How are we going?
Thanks for joining us. Now, before I start, I'll run through a quick bio. Mike has an extensive and broad knowledge across the construction sector with a primary focus on external facade, durability and thermal performance. Having started with the rock coat plaster business in 1990 through to today with Resene Construction Systems, Mike has sat on the board of the Cladding Institute of New Zealand for a number of years and was a committee member for the LBP external plastering class when LBPs were introduced to the industry. Mike is also an honorary member of the New Zealand Institute of Building Surveyors. Now, we will have time for questions today, so please do type them into the box and we'll try and answer as many as we can. As usual, if we don't quite get to you, we'll certainly try to come back to you after the webinar at some point to answer those questions directly. Righto, we will turn our webcams off now and I'll hand over to you, Mike, to kick things off. All yours.
Very good. Thanks for that, Rob. Welcome everyone to my presentation this afternoon, Plaster Coatings Inside Out. So today I'll be giving a very brief history of plaster as a material, its application, all the way through to some modern products and systems that are being applied today, and also some fine examples of some projects around New Zealand and in Australia that I wanted to discuss and show you. The important thing about this type of presentation is actually, if you have it's like testing. If you actually sit in a test, you actually understand, have a greater depth and understanding of the materials that you're potentially specifying. And it also gives you a great insight and appreciation of how they can be applied, and equally you can push the boundaries of architecture. So as a starter there, so plaster as a material alongside of the application techniques that stood the test of time. It's known as a wet trade, which are trades that use materials that are mixed with water. So essentially start out dry, add water to make them into a fluid for its particular application. So plastering, brick and block laying, tiling, generally the most common today. The wet trade's also very much a finishing trade. They make the rough look great through their hand applied skill and knowledge. I thought I'd just start with a couple of images here around projects that we worked with, and this is Rufus Knight, and this was presenting at the opening of the New Zealand room at the Venice Biennale. The Venice Biennale happens every couple of years in the architectural sense, and this was a project that Rufus approached us on. This room, the New Zealand room, was inside a 15th century building in the heart of Venice. The very strict specifications in terms of what we could do in this space. So there could be no damage. I mean, you're talking 15th century, so you could damage nothing in this property. And so what we did is we built partition walls here in New Zealand, and then we coated them with a rock coat natural clay plaster or clay decor plaster. The reason we chose that product is that it contains no cement or limes, so that it's not, if it got wet or damaged and it sat on one of the timber floors here in this particular building, it wouldn't leach out and leave lime marks or cement marks. Equally, it could be repaired, and we did the base coats here in NZ, and then when it got to Venice, we had one of our artisan plasterers out of Castelfranco, which is just out of Venice, go down and apply. We'd already mixed some product up here in NZ, and we sent it over with this wall, and he went up to the site and applied these different strated, layered, coloured effects over this wall for this project. So, been involved with these types of projects. The next, the project, I mean, I love this one with, I mean, maybe A, it's Resene's colour, and B, it's got loads of plaster on it. But this is Louis Barragan, and a Mexican architect. He was a second winner of the Pritzker Architecture Prize. He was just a minimalist. And he adored colour and plaster. So hence why I sort of popped that one up there. This actual building, this was completed in 1948. This project. It's Castro Studio. It's in Mexico City, and it's actually listed as a World Heritage Site by UNESCO, and that was listed back in 2004. Some of you may or may not know this project. So I thought I'd go back to a New Zealand architect. So even though this project's in Shenzhen in China, a bit of New Zealand architectural prowess here, and this is Fred van Brandenburg, very much an Antoni Gaudi influenced project, the Marisfrol campus, costing billions of dollars. I mean, this is a 120,000 square metre complex in Shenzhen in southern China. And it's perhaps the single largest project undertaken by an architect from New Zealand. This project included a number of our products, in particular our lime-based plasters. So this project, you can see there's some things you can manufacture, but creating these curves and shapes and forms by hand is something you just can't replicate, generally speaking, out of a factory. So it was a nice pure example of craftsmanship and workmanship that we like to promote these days. Now, this is a little bit selfish in that I'm saying, so going back, the art of plastering is as old as civilization. So more emphatically and slightly biased for obvious reasons, without plaster, there is no civilization. So if you go back millennia, our ability as humans to leave a cave, build a shelter, and then coat that shelter with an earthen plaster enabled us to essentially create a cave wherever we wanted. So that was the sort of the setting up of towns and cities. As crazy as that sounds, that's pretty much how it happened. I mean, we could find rocks and build shelters, but in the winter we needed to stop that draft and the weather, so we put on some very basic earthen plasters back in the day to assist us with making life more comfortable. This will be as deep as I sort of go on the history side of things, but it's quite important. So we're going back at 7,500 years ago. Beyond is from Turkey with dwellings and mud brick walls through to the pyramids of Giza, as shown you before. The pyramids of Giza, they had original lime plaster finishes to the interior and exterior. Then we get through to Vitruvius in the 8th century, and Vitruvius, he's a Roman military engineer. And when you consider sort of knowing Greek and Roman structures still standing around Europe to this day, equally much of his writings are applicable and in use today. In particular, if you've ever been to Rome, the Pantheon, it remains the largest unreinforced concrete dome ever constructed, with a diameter of 43 meters at its base. And you need to bear in mind that concrete used was not as you know it today. It was pretty much based on lime and pozzolanic cementitious material. We do use pozzolanic material today. It's a very high strength mortars. Then we get through into the decorative, and this is where the coloured renders and plasters started happening between the 13th and 19th century. I'm just thinking frescoes in the late Renaissance period, so Venetian plasters, and you'll hear this term Venetian if you've been to Italy, you'll see these polished glass plastered walls, and then we come all the way through to some modern day facades now, which we're not just plasterers anymore. We actually supply and install full systems for the exterior of projects. So the basic types of plaster, you have your gypsum, your lime, your clay, cement, and more modern acrylic technology these days. These basic ingredients are the dominant raw materials or binders that can be blended in a multitude of combinations, and that will create specific requirements depending on the specifications. Other fillers such as sand, adhesives, water, to make it pliable and applicable is added. Every different type of material, every different base, like on this in the slide here, we're seeing clay, lime, and cement, and they all have various properties and qualities dependent on the application. I'll start with clay. So vapor permeability, amazing breathing capabilities, very poor weather resistance, and it's quite a soft plaster, but it has a very low embodied energy, so it's very cost effective to produce. When I say it's weak and poor weathering, so for example, you won't unless you're building with 2 meter eaves and you're going to get no water on the surface, then you probably wouldn't use clay plaster as an external render. You'll generally use it internally. It's very good with vapor breathing and also relative humidity. So if you want to do an amazing wine cellar and keep a relative humidity, then clay lining that would be brilliant. Lime, excellent, or good vapor permeability, good weather resistance, strength pretty strong, and it has a medium embodied energy for its manufacture. Cement, not very good at breathing, very good weather resistance, and it's very strong, but it's brittle, but it's very expensive to manufacture. So the very first plasters, they were earthen. They were simple mixtures of clay, sand and straw, and they required no furnaces and pretty much dried by the sun. It's actually our oldest continuous building tradition, and clay, to this day, clay is readily available only a few feet, or as little, if you live in Auckland, as little as a couple of inches under your feet. Not that all clay is made equal. Certain clays are more suited to render application than others. One of the most unique characteristics of clay that distinguishes it from other binders such as gypsum or lime is that it only has a mechanical set. So that's to say it doesn't undergo a chemical change. So when it goes from wet to a dry plaster, it just simply dries out. It's very plastic when it's dry, so it's workable. And when wet, just what is needed for a good plaster. However, as the water evaporates in the plaster, the platelet structure of the clay consolidates and becomes rigid. One of the benefits I mentioned previously was that because it has a mechanical set, if it gets damaged, it can actually get re-wetted, hence why it can't be used as an external application, and you can actually rework it and you can resurface the material to make it good again. So the most common interiors and our rock coat earthen clay and clay decor finishes, we use a dominant white china clay rather than what you would conventionally see as a beige clay. We use a china clay so that we can actually add color to it and get consistency of color. Gypsum, everyone knows gypsum obviously just with plasterboard is the most common thing, or stopping compounds. The story goes, a little bit of background on gypsum. So just by chance, apparently, that some rocks of gypsum or lime, they were selected to build like original crude kilns for firing a pottery. And the heat of that fire, it drove off the water, which left friable rocks, which quickly crumbled into a powder. When they came into contact with water, they formed a paste, and that apparently quickly hardened, and voila, lime and gypsum were invented. Lime mortars are interesting in that, like many of us, we get better with age. The improvement occurs due to CO2 or carbonation. So wherever new lime is exposed, and if there's minor cracking or damage to the lime surface, it actually takes in more CO2 from the air and seals essentially those micro cracks. So when we're looking at doing work on historic buildings and the like, very rarely will too much cement be allowed. They'll rather do pure lime mortars for internal finishing of those areas, equally because they breathe a lot better than cement-based mortars. So there's not too many architects there that work in the historic place that won't be looking at using lime type plasters or clay with clay. Cement's obviously the most obvious and most common today in the broadest sense. So cement plasters, in essence, they're a mixture of silica sand, limestone, clay, chalk, and other ingredients that's melted together. And this is where probably the high embodied cost comes in, because the temperature of these that it takes to actually melt these components together to then create this powder is very expensive. Cement plasters are the most common, and for predominantly external plastering today, due to their hardness and their durability. Cement's still the most common binder for plaster anywhere. The original cement was Roman concrete, and that was invented over 2,000 years ago. And that's what I mentioned earlier around the Parthenon. And there are modern Roman cements, but they're generally quite expensive. I'll just get into the next. And probably our most modern that we have available these days, and this is more as a finishing type render. It's around our acrylic and acrylic plasters. They're a mixture of acrylic resin, calcium, quartz, silica sand, titanium. Titanium just so we can achieve some colours. Acrylic replaces the cement as the binder in these products. These products are highly flexible and crack resistant, and they eliminate a lot of the site blending that was common back in the day, where you'd have, for accuracy purposes, you didn't just mix up a couple of shovelfuls of sand and a couple of shovelfuls of cement, mix it all together and add some water. These are just far more accurate in terms of the consistent finishes and colours and things that you can create with those. Looking at the application, the tools, techniques and finishes now. Originally, I mean, plaster, yeah, it literally was hand applied until tools were developed for specific applications. And the products, the tools, application techniques, and the experience from the plasterers, with the vision from our clients and architects, determine what can be achieved. This is just a small range of tools you can see there. Contractors have boxes and boxes of different types of tools and rollers and they're getting into a lot of templates now where you can create multitudes of different effects and finishes with the range of different types of plasters. When we're looking at sort of modern texture plaster finishes today, traditionally these are there's a sponge finish. Essentially, it's still applied by trowel, but it's finished with a sponge to give you a lightly raised, grainy surface. There's a floated finish, which gives you like an inverted version or a reverse of a sponge finish. Then we have the brush finish, so you can actually, these are all exactly the same products. They're just finished with different techniques. So obviously the brush technique, you can do vertical or horizontal striations in the actual surface to create these different effects. You then get back into some more traditional, and these ones are more traditional solid plaster. The first one's a terraline finish, and if you haven't seen terraline or heard of terraline finish, back in the day before they had compressors and hopper guns, you're generally the little tool you can see down there with the handle. You'd fill that with plaster, and there's little teeth inside there, little flexible teeth. And you would actually stand there and you would wind that to create the texture, and it would flick out plaster onto the wall surface to give you a textured finish. Dry dash in the middle there. When we're doing remediation work or historic work, we use this particular finish with Colin McKenzie Plastering in Auckland. And when the Alan Melville Centre renovation was completed, we used that technique and product. The most challenging thing was actually getting the right aggregate that was as close as possible to what was originally applied back in the 70s when the surfaces were done. And the final one is rough cast. And rough cast was a very, very fast and literally a cast plaster onto a rough base plaster of render. You see this in a lot of old schools in particular, where they created a very, very heavy finish to try and cover up some of the underlying substrate views. Moving on to the interiors, so these are becoming very, very popular, just because people wanting that point of difference, those natural looks. The first one up there is a polished surface, so you can have a very, very smooth polished surface. We have got our Otsumigaki, which is our Japanese clay lime plaster finish, or the Venetian finish. So the Venetian I mentioned earlier, where we started in history to actually add some colour into the plaster. The Venetian plaster is what we would term a glass finish. so they are as smooth as glass, and they will reflect a person's image. When you look at them front on, they're flat. I'll try and go back a couple of slides so you can see the reflection from this. This doesn't use an automated buffing machine or polishing machine. This is literally polished off the trowel, and he's using a plastic polishing trowel there. And this particular plaster Venetian, is the aggregate inside this plaster would be as coarse as toothpaste. It is so fine. But you can get these beautiful burnished, polished glass effects. When you look at these walls front on though, they don't look shiny. They look like it's a nice flat uniform surface, but not until you look across them you get this glass finish. Next is using a velvetina or lime-based plaster. This is a travertine type effect where you would actually trail the product on. We would brush through that, and different techniques will achieve different travertine type effects, and then we tip it off and tighten the surface with a stainless trowel. The next one is our distressed. People they want the look of that natural organic type surfaces, so we use the Otsumigaki in this particular product, this particular slide. But you can use different ranges to create these types of distressing. Just depends on the amount of distressing, for example, you want. And if you look at the next slide, this is a clay plaster here, which is our rock coat clay decor, and that's got reasonably heavy distressing in the surface. And then we go to the scratch light surface, which is a velvetina, lime-based plaster, which is very, very fine scratches. The surface has been closed up a lot more, but it's a very, very flat, natural matte finish with this particular that particular product. We also do the vertical combing. That can be vertical or horizontal, as a note there. We generally would use either a lime plaster like a Marrakesh or a clay decor plaster, just because of the heavier build we can get with that product for this type of finish. So plasters need substrates. So here we'll look at some of the original substrates through to more modern counterparts that are being applied today. So original, I have to throw that one in there with a bit of mud and brick and stone. So these are the original sort of little structures there, I suppose you say, with mud brick, original and ancient DIY stuff. The lath and plaster. So the two images on your right, one was lath with bamboo, obviously out of Asia, because bamboo is very, very prevalent over there. So they would do the lath and plaster over bamboo, and to this day they still do use bamboo as a lath or a background for when they're doing their natural plasters. The lower one there is pretty reminiscent of what you would see in NZ, in New Zealand, with the traditional lath and plaster for the interiors. This is obviously the days before we had plasterboard. So if you ever owned a home in the pre-40s in NZ, you've generally probably done a renovation, you've more than likely come across lath and plaster, until obviously plasterboard came in and became a very popular method and faster method to actually finish off interiors. So the lath in general is a pretty straightforward technique in that there's battens applied to the wall, the plaster's forced onto that surface, and the actual the plaster forces through those lath and essentially hangs on that surface. And if it's older lath and plaster, they would use horsehair as some reinforcement to try and tie those plasters all together. And then for exterior use, traditional solid plaster there over a rigid or flexible backing. Generally, you would find with more modern solid plaster that would have more solid backing or rigid backing. Prior to that, it was a couple of layers of building underlay, building paper, and chicken wire, which was fixed onto the structure. You don't tend to see too much around that space these days, just with the modern technology and systems. But certainly, solid plaster is, in terms of application and historic, and also on mainly masonry work, you'll see a lot of traditional solid plastering techniques being applied. This brings me through to some of the modern substrates and options available for clients, and so there's multitudes of substrates available in the market. each with their own features and benefits. So that the most common for exterior would be obviously precast. Then we get into your concrete blocks. We have your ICF, insulated concrete formwork, which is becoming more prevalent, but obviously with the changes to H1 and people wanting far more energy efficient homes. Then you have our lightweight concrete or Integra AAC panels, and then some of our latest stuff that we're doing is our Xtherm. So our insulation boards for outsulation type systems. And I'll touch on those a little bit further shortly. So the interesting thing is that plastering, it's not just plastering these days. I just touched on earlier, plastering's evolved over the years, and it's mainly due to the modern sort of proprietary systems that not only have plaster as a finish, but include flashings, specific substrate installation, coatings, instructions that result in an entire facade supply, install, and finish, as opposed to the historic method where the builder supplied and installed the substrate, the flashings, and the plasterer would turn up, apply the plaster, and then the painters would come through, seal the openings, finish the plaster, and then paint it and protect it. So back in the day, I mean, plastering just even as early as sort of Second World War, sort of in the 30s and 40s and pre that, everything was rendered. All whole interiors, ceilings, the art of plastering is very, it's reduced in terms of what it used to be in every residence and building in the country, and it's certainly a trade we want to try. We're maintaining. When we discuss external plastering, all works these days, they need to be completed by trade qualified LBP registered contractors, because external cladding, it's a critical aspect of obviously the structural protection, also the aesthetics and the durability for every project that it's applied to. So there's two LBP license classes, licensed building practitioner license classes for external plastering. The original is traditional solid plastering, as we touched on earlier, and then there's the PPCS, or proprietary plaster cladding standard. So the solid plastering was traditional. It required a depth of historical knowledge, plaster design mixes, application techniques, running molds and cornices. Believe it or not, you couldn't back in the day walk into your local merchant and pick up, one of 10 different profiles already pre-made and formed for you. You would actually, the plasterer would actually run these molds and cornices. You won't find too many these days doing that, except in historical remediation projects. Generally that doesn't include the substrate or the flashing installation, generally speaking, these days with the traditional solid plastering. With the proprietary systems, these are more modern plastering trade that not only includes the plastering and finishing the exterior, but also the substrate and flashing installation. So in many ways, a modern plasterer in New Zealand not only plasters the walls, but they're extremely proficient with the substrate installation, flashing details, intersecting trades, and equally the finishing and paint application. So in terms of what these substrates look like these days, there's two different methodologies. There's the direct fixed, which today is generally applied directly over a masonry structure, over a masonry substrate, be it brick or blockwork, and or it's a cavity. So generally, if you're installing a substrate over an external wall structure in the residential and or commercial construction sense, they're always applied over a cavity. And that is to allow for any incidental moisture from roof connections, penetrations through walls, to escape without damaging any of the structural elements of that particular building. I'll just click through this next one. So with changes to H1, there's some key things when considering the thermal performance. So we have a look at these insulation boards, and So insulation is sort of more of a contradiction in terms of, for our situation, when you consider that what we try to do is we install our insulation boards or outsulation panels to the exterior of a building in terms of, rather than insulation, we call them outsulation panels. There's 3 different types at this stage for us. EPS, which is traditional expanded polystyrene, XPS, which is the blue one down in the bottom middle, and that's an extruded board, so it's essentially, it's not expanded, it's extruded through a machine. It's generally a lot harder and a lot denser, and you get a higher insulation or thermal performance than you would with, for example, EPS. PIR is polyisoanurate, and that's, once again, it's an extruded board that we can have in selected widths and sizes. But that, and one of the things that I need to note about this particular product, the PIR, we have a system called Xtherm Gold, and the reason we've pushed down this track with Xtherm Gold is that you're getting a very, very high thermal performance, over double what the EPS will give you for the same thickness. But it's also made here in New Zealand. So with what's happened in the last couple of years, it's a good way to have a think about your external insulation for your new builds. I did miss on that one. I'll carry on with this now. In terms of that thermal performance, the insulation, more and more commonly we're getting masonry overlay systems, and there's the 3 different, you still the 3 different substrates there, be it the EPS, XPS, and PIR, and that provides the best performance, thermal performance for a masonry build. So if you're doing if you have a concrete block structure, the days of essentially strapping and lining and putting insulation inside the building, but still not stopping that cold entering that blockwork and that blockwork structure. We're trying to take the dew point to the outside face of the masonry, or to the underside of the coatings, in fact, rather than put the insulation to the in wall. So this is a very, very good way to get the best thermal performance to the outside of a masonry structure or a concrete structure. I thought I'd jump in and go through and talk the next few minutes just around some of the projects. These are some of the exterior projects that we've been involved with, and just looking at some of the finishes that we've actually applied to these. Obvious, this is a brick surface, and we see this quite often in large subdivisions. I know particularly up in Auckland, you from a distance it looks like a plastered surface, particularly when they get coloured, because people like that flat monolithic surface. They just want to have this much heavier textured surface. This is actually a Jack McKinney design, so if you get a chance after this presentation, have a look at Jack McKinney's website. This one's called Under Ivy, and this is he carried this mineral brick bagging through to the whole interior and everything in this particular project. One of the key things with the brick veneer, obviously, it's a porous, so it lets water through. When we talk about the brick veneer cavities, we talk about the cavity constructions we use today. The dominant theory on the cavities all came about from brick veneer structures, and that the brick veneer, they have a very large cavity because it's a wet cavity. But whereas when we talk about our external plastic claddings, where we're supplying and installing the substrates, we only need a 20 mil cavity because we've got a finished surface on the outside of that particular substrate. This particular project's in Christchurch, and it's interesting to note this project here. This is post Christchurch rebuild. This is what's sort of happening in Christchurch. What you don't appreciate from this slide is underneath all that grass there is the car park underneath the house. What you don't see here is what's this is an opening here. Excuse me, where the driveway goes underneath this project. So it's pretty pleasing to see this type of structure getting built in Christchurch. This was a couple of years ago now. So that was used our lightweight Integra and lightweight concrete system. That was on a 20 mil cavity. We had acrylic pre-coloured Classico texture, and the application is trowel applied, and it's got a float finish. Heading into once again, this is another Christchurch project. This was shipping and route design out of Christchurch. Used our Integra lightweight concrete. The clients wanted a very smooth surface, so they selected rock coat Serrano texture finish, which is coloured trail applied finish to give you those very subtle variations in tone across the wool surface. Another one in Christchurch, recently completed. This is once again our Integra lightweight concrete. Had the Serrano concrete finish on it, and it's a stunning. I like this property just in terms of its sharpness of clean lines. This one here is one in Auckland, where we've gone a bit more traditional. The clients want a bit more traditional sort of design. This is still with our lightweight concrete substrate and rendered, but we actually literally routed through the first 10 mil of the panel. Every horizontal line in the wall surface you can see there has been routed and then free-formed by the plasterer. The moulding work and detail work and keystoning at heads of windows and arches and moulding work runs around the entire property, and that's use the traditional mineral plaster finish for that one. And we actually coated that. There was an aqua shield finish on that, so Resene aqua shield for that real mineral flat, not glossy type paint finish. Masonry block, as I mentioned earlier, masonry block is still very prevalent in the construction market with our masonry render system. This is a private residence that was in for Master Build House of the Year last year for the North Shore, and that was our floated texture finish painted with Resene X200. This project here is in Timaru, and this is features our X-Therm Gold for our high performance thermal requirements, and that's fitted over a 20 mil timber frame and mineral textured finish and coated with Resene X200 again. For the specifiers in the room, we have multiple tools and samples of all of these different products that you can show your clients, or you can request for us to come in and show you. We have our architectural models there you can see, which gives a full makeup of each of the different products and systems. That shows you the different flashings that are incorporated, and then we have a full range of textures and little mini samples as well to assist you in your product selections. I should have touched on this particular project earlier, but this the slide you can see here, it was a project that we completed in Australia, and this is right on the coast, and this particular client obviously doesn't like straight lines. I'm sure the glazier was scratching their head when they had to try and fit that section of glass around that curve, but there's our full Marrakesh line plaster interiors to this particular project, and it was a shotcrete exterior that was then rendered and coated, and you can just see it's beautifully up there on the coast. Even under this residence, there's a mechanical roundabout, so the cars actually drive in underneath the house, and actually this automation system turns the car to point the right way when it gets out of there. So as I just mentioned, so we used our rock coat Ultimagaki and our Marrakesh line plasters, and if you're ever driving up the Gold Coast, see if you can spot this one. I can't tell you where it is, apart from saying it's in the Gold Coast in Australia. Our Ultimagaki clay plaster finish would have to be one of the most popular finishes we have in the market. Once again, pre-coloured natural clay lime. Ultimagaki is Japanese, and it's a traditional Japanese plaster and a plastering technique. Ultimagaki essentially means pressed plaster, which makes it firm and it compacts the surface, but it also gives you some different patina effects depending on how you finish it. We also apply liquid Canuba wax over the surface to make it easier to surface and look after. So this is in the Kiwi Property Head Office in the Vera Building in Auckland. If you've been recently travelling, and I know there's a lot of people out there that have recently travelled overseas, if you're coming through Auckland duty free and you need to do some collections, have a look at the walls in there in that collections area. That's all it's a lime plaster, pure lime plaster finish, called Rocket Marrakesh, and it's all pre-colored, and the detailing and the work in this particular project, all the negative detailing, creates some really neat effects. And that was created by Zane Pilkington of Pilkington Interiors in Auckland. Otsumigaki, once again, hand applied and polished. This is a very high polish surface we achieved over this particular project. You can adjust the level of polish and finish that you want with these particular products. Otsu, once again, this was in for NZILA awards this year, and I'm not quite sure where it ended up, but it was the Buttle Finley, so it was certainly highly commended. And that was done in Resene. That was Resene Silver Chalice, that project. This project here, this is a Jack McKinney project, and if you have a look, it's called Super Taper, this project, and please have a look at Jack's website around this project. It's a phenomenal little design that he's achieved here with this project. This was our Otsumigaki clay lime, but it was not polished. They wanted a very, very flat, natural finish. As you can tell from the interior design of this project, there's it's natural terracotta tiles, natural timber surfaces throughout. So very natural, authentic. This was the other one from Jack, and I mentioned about the bag bricking that I showed you earlier on in the exteriors. This is the same surface wall area, actually returning back inside the building. So essentially, that's a fine Fitzroy plaster, what we call a Fitzroy plaster, that's been sponged and then bagged to close the surface up, and then it has an Aquapel surface sprayed on it to give it some water resistance and weather resistance and cleanability. This project was up in New York Grill. This is up in Newmarket, New 277. And this was a lime plaster, that very, very light scratch surface. So if you get a chance and you're looking for a meal out, stop in at the New York Grill there in Newmarket and have a wee look at what we achieved on the walls in that project. One of the things with the Velvetina finishes or lime plaster is that it's a very flat finish. You have very little sheen on that surface. All right. Unlike this one, when we're looking at the ceiling in this particular building, this was the Harman Horton Lusk offices, and you can see the gloss on that ceiling, the work that the guys applied into this particular project. This is your Venetian. This is your glass reflective finish. It's a phenomenal surface, and once again, it's like I say, the mirror type finish, and they're very, very fine plasters. Jumping into Marrakesh, this is a traditional lime plaster, and it's a very high build plaster. So if you want a very hard, durable surface, then this is certainly one that you would look at. Traditionally in the hammams and palaces of Morocco, these are what they term Tadillac plasters, and finished with black olive soaps to help the carbonation of the plasters. So we're using some of those very ancient techniques, even with modern day application, which is quite nice to see. And this is the clay decor. So this is up at the Mahi clothing up in Newmarket in Auckland. This is a comb plaster finish. So vertical combing to give it that rustic, almost a rustic uniformity, I suppose you might say. And then looking at our Serrano finish. So I showed you the Serrano earlier on some of those architectural projects for exteriors, a concrete finish. This was done at Allbirds in their flagship store in Auckland and Britomart. These panels are all done individually with individual colours. The contractor actually was all trowel applied, but then he brushed the surface or dabbed the surface and then tipped the plaster off when it started to go off a little bit. So you actually get this little distressing over the surface. Now every panel was different, and don't ask me how many panels there were, but they were by the dozens. And Zane Pilkington from Pilkington Interiors just took all that work. If you've been to the Auckland War Memorial Museum lately, you go into the gift shop, you'll see this finish here, and this was created to with our clay plaster to try and emulate sort of a layered earth effect, or a very natural sort of layered earth or strata effect. And that seems to be becoming reasonably popular. We did that on a couple of projects recently, but this would be the more common if you're up in Auckland. But for those of you sitting down in Hamilton, we did this clay plaster. We did this clay plaster finish down there, and the brief essentially was around Serengeti. So I think we've achieved the Serengeti quite nicely there, and that was applied by an artisan plasterer, and we used two different products there. I say we did with the clay plaster, the clay decor. We actually went through with our Otsumigaki just to do some highlighting and some depth changes in that application. So you can keep on going and we get into these rustic wavy effects. This is sort of a raked through the tip of the trowel and then tipped off to create those flat points above the recesses or the swales in the plaster. As mineral, just a natural mineral plaster. This particular project here, this is the Ebb Hotel in Dunedin. And this is up for NZIA National Awards currently. And that was, it's a beautiful hotel. And that was a natural mineral plaster, burnished concrete, so on a very neutral palette, with a little bit of the patina on the surface. And that's, like I said, it's up for the awards now. So if you're in Dunedin or getting to Dunedin, definitely stop in there and have a look at that particular project. Untouched World Kitchen in Christchurch, once again, the natural cement-based plaster. When I talk about these mineral finishes, we generally don't colour those. They just come out natural. It's a natural grey cement and sand colourings. Heavy plaster finish here at AJE, mineral plaster again, uncoloured. It was applied quite thick and then just hit with the sponge. Literally hit with the sponge and then sucked off to create that lifted plaster, so the lifted surface. Otsumigaki again, this is down in Dior, flagship store at Commercial Bay when that opened up. Obviously with the Vietnamese sort of hint here with the very distressed plaster. This is, you got to bear in mind when you look at this distressing and the brushing and the techniques applied, this is about 1.5 millimeters thick. So we're not talking massively thick plaster finishes here to create these very, very subtle effects and finishes. Clay lime, so if you've ever had Nandos up in Queen Street, you have a look when I talked about templating. We did a base plaster on the walls here with this lighter tone you can see. We let that dry and we actually had a CNC cut template with that brief from Nandos designers saying this is the shape we want. So we created a CNC template. It was 1.2 meters wide by 3 meters long, and we tacked that in place and then applied that next tone or that depth of color. And these ridges here, this is probably around about 3 millimeters thick, 3.5 millimeters thick, creating that different toning and different colorway. As with our external finishes range and systems and coatings, we have a full range of artisan interior sample boxes, and we have our latest artisan interior inspiration book. It's over 60 pages of a number of those projects you've seen there. So to give you a bit of an idea and a guide on what to look for. So we've gone from this to this, and it only took 7,500 years. It's been an interesting journey, but if you want to learn more about what I've discussed here today, or look a bit deeper into some of our systems and products that are available, visit our website, follow us on, we've got some beautiful projects through Instagram and Facebook, and projects under construction on LinkedIn. So have a look at Resene Construction Systems, and yeah, I'm happy to take some questions.
Thanks very much, Mike. I'll flick our webcams on so everyone can see our ugly mugs while we do a bit of Q&A.
Speak for yourself.
There's some really interesting techniques in there, and it's kind of when you look at it, you realise again back to Roman days and around then they were pretty good at creating things, weren't they, for that we're still using today, I guess, with a lot of the techniques and things. But even particularly with some of the things you just showed there near the end with that templating and the effects and patterns is pretty impressive. And I'm already thinking about the house I'm going to build and the render systems I want to put through it. Like I'm sure others are as well that are watching. So what we will do, we have had some really good questions come in. I'll let everyone know that we're about the 50-minute mark. So I'll call it when we get to 60 minutes. I think we might just carry on with our Q&A because there's some interesting ones here. But I'll let everyone know that's watching when we get to about that 60-minute mark if you want to bail out if you're moving on to other things today. So I'll just crack into these questions. Now, Lynette Arnold, you've stolen my question that I was going to ask Lynette, but thanks for firing it through. Could you cover how the internal surfaces stand up to wear and tear and cleaning, please, when compared to normal acrylic paints?
Yeah, you need to be more careful with them. There's no two ways about it. We can actually apply, and we've just recently been working on a couple of projects where we apply Resene concrete wax, but it's a special application. So it's not just apply the Resene concrete wax, you actually need to get the dilution ratios correct. So it does penetrate because they're natural plaster surfaces. With any of our natural render surfaces, we do not recommend that you put them into wet areas or areas where you're going to be coming into contact with caustic cleaners or anything a lot like that. You need to be careful with those surfaces. There's no two ways about it.
Yeah, and I guess we would say the same with paint coatings as well. We've got varying levels of products, I guess, that are around durability, but that ultimately at the end of the day, that interior surfaces will be damaged if there's mechanical damage or impact damage. So maintenance is required, certainly.
Yeah, I think it's having appropriate coatings or appropriate surfaces for the locations. If you're going to have a natural material like a natural material plaster, like an artisan plaster, as a splashback, possibly not appropriate. Just because it's going to be getting spray and wiped and cleaned consistently day in, day out. It's like I won't promote that you put these products into shower cubicles because you're going to be getting soap, and believe it or not, there's chemicals in everything we have. And when I've got these beautiful natural plaster surfaces, you just don't want to be putting non-natural cleaners on them. One of the things that we finish one of our plasters with is a black olive soap. One of the most natural cleaners available. That's just that it's reasonably difficult to get hold of. But for our Tadillac plaster, you actually can clean that surface, and we highly promote that you only clean it with a black olive soap. So yeah.
Yep. Interesting question in from Graham Durkin. Thanks, Graham. Is there any additional preparation or specific systems for locations influenced by environmental conditions, e.g. being in proximity to geothermal activity areas with high level of sulfurous gases, and being close to coast with salt-laden air? Same question goes for locations which are prone to seismic activity. That's a big one for you.
Yeah, so I'm assuming, the interior side of things, yep, not an issue. But in terms of exterior, what we're normally dealing with, we do have coastal zone requirements, but with all of our external facade systems, coating systems, all our fixing points, the fixings that go through to the structure are fully encased. So they're not exposed fastener. So in that sense, even in a sea spray zone, we do not need to have any. We don't need to specifically specify stainless because the fixings are fully enclosed. If you do want to go into stainless steel, we absolutely have full stainless fastening. We do have those specified on occasion for specific projects, but they're not generally a requirement as such. Seismic, all our systems post Christchurch. Our head office is based down in Christchurch, and is a pretty good example of the performance of the external plaster cladding systems down here. Is the dominant performance was lightweight systems that exceeded expectations. Anything that was heavy absolutely got smashed around, i.e. your bricks and your stonework and things like that. But it led us to do some even more testing at at the Halfin lab, where we did some big seismic testing up there. And we were, with our standard specified system, for example, our Integra lightweight concrete system, we can push our wall up to a ULS of, I think it was 23 millimeters, ultimate limit state deflection horizontally. And we also took that wall up on that system, I think it was to 4.65 kPa negative pressure. So in terms of wind loads, yeah, we were getting some pretty significant results around that space.
Lightweight's certainly the key for a lot of areas in construction, isn't it?
Yeah, very much so.
Yep. Good question in here from Mike Rudolph. How do you protect those monolithic finishes from moss, fungal growth? There does appear to be sloping edges for water runoff. I guess that's the key.
Yeah, I think so. If you don't clean the outside of your house, and because that's generally what mold and fungi will grow on, they'll grow on the dirt that's sitting on the surface, as with anything. And so if you keep the exterior clean, I'm a huge proponent of you keep your joinery clean, because that's generally a very cold surface, and dust gets attracted to those surfaces, those very smooth surfaces. If you keep your windows clean, you will stop that runoff happening at the jambs and sill junctions, and you're having those stripes and streaking below wall areas, below the window, should I say. It's a pretty straightforward process in terms of giving it a soft wash, an annual soft wash at the appropriate time of the year, and you'll be fine.
Yep. Yeah, and I guess that moss and mold growth, algal growth, is we get a lot of questions ourselves through our technical lines and asking if there's paint products that can reduce or eliminate, and it comes down to the environment. So if there's if the environment's correct for moss and mold or algal growth, it will occur, and we can slow it down or slow the onset, but we can't eliminate it with paint products.
Yeah, there'll always be those southern sides of houses, or the sides of the houses that just don't get any sun, and they're just a perfect environment to grow. So if you literally, if you keep that surface clean consistently, and if you know you've got one particular area that you need to take a little bit more care of, then do it. But the paint coatings and systems, they're not overly impacted. I mean, if you're ridiculous about it and you see mold growing on something and don't do anything with it for 12 years, and then make a phone call to our helpline and go, I've got a problem. You know, I mean, it's all a bit about self-responsibility, and I mean, nothing's self-cleaning. I know there are some people out there that say their stuff's self-cleaning. I certainly won't be down that. We won't be promoting that.
And yes, we have this paint products and the like, and I guess just to clarify that in simple terms, often they're hydrophobic coatings, so they're not allowed. The water's beating up on the surface, and what that does is it doesn't allow the dust and dirt and grime to settle on the surface because the water's beating off. So yeah, that definition of, is it self-cleaning, or is it just not allowing things to settle on the surface in the first stages?
I think if you think it's too good to be true, then it probably is.
Yeah. Now we're going to carry on with some questions here, but I just want to let everyone know that we are coming up to that 60-minute mark. If there's people out there that need to bail, but we've got some cracking questions here. So as long as you're okay, Mike, we'll carry on for another 5 or 10 minutes. Good stuff. Now there's an interesting one. I had written one down myself, and L.R. Rasmussen's come in with a one or 3-letter question, VOC, but I'd written one down around how the industry might be changing with the environmental and sustainability demands that are upon us now, and that we're all working towards big changes. So what are you seeing, just in a general sense, in the industry?
In a general sense in the industry, so some of the key stuff that we look at is in terms of sustainability, can it be recycled? What is the total makeup of the system for us? For example, if you look at an insulation or an outsulation panel that I mentioned earlier, for example, an X-Therm Gold, we're talking 96 to 98% air from the original product. So you're getting a massive product volume out of a very low input. And equally, the lifetime benefits of the thermal performance, the non-degraded thermal performance of that product to the project is significant. We also look at our cement. So all our cement that we supply and use here is through local manufacture, through Golden Bay. We don't import our cements from offshore, so it's local supply, and I think that'll be some of the key terminology that I think you'll hear in the next couple of years, particularly because of freighting costs and international shipments and supply channels, is insourcing. So if you can keep it local, that's going to be better for your business. Hence why I talked about that Extherm Gold earlier. It's made here. All of our lime that we have for our renders is all manufactured here in New Zealand. Out of the Hawke's Bay, we get all that. All our calcites and fine limestone and limestone fillers all come out of the Waikato and Central Plateau. So wherever possible, we try to keep it local. The three letters that were mentioned at the very beginning of the question, the VOC, we've had testing, and one of the beauties of what we have up on our website is if you jump into one of the particular products, be it our, I'll say Otsumogaki because I know you got some questions out there around Otsumogaki. So Otsumogaki, if you look on our website and go into interiors and click on that product and go down the specifications, we actually have all the testing. We've actually done independent testing for the VOC components, and each of our natural materials listed, be it the Velvetina, Otsumogaki, or clay decor, even Venetian, have less than 1% VOC content. There will always, if someone says it's got 0 VOC, you're probably eating it. You know, I think it's pretty difficult, particularly when you're talking coloured product, because we're adding colour to it. There's going to be some component of VOC in there, but it's so low. And what we do is, and we keep it very transparent, we actually put our entire test reports up online, so you can qualify that. You don't just need to take our word for it. You can actually have a look at our full test reports. But sustainability is a significant issue for all of the built environment going forward. There's no two ways about it. But we're doing a bit to try and keep everything as sustainable and as local as we possibly can to reduce our carbon footprint.
Yep. Great. Now, another question here that I had, someone stolen my next question. Jonathan Jones has asked, presumably there are cost implications for different finishes. What does the price range look like? I was going to ask it slightly differently, just around, you know, cost per square meter, or is there a general rule of thumb on this, or does it vary wildly?
Yeah. So when we're talking, so on the interior side of things, firstly, if you're looking at something like our Marrakesh would be the most expensive product, just in terms of the techniques and the skill involved and the thickness that's applied. But you could be talking $350, $400 a square meter for that particular surface finish. Depends. If you're just talking one flat wall area, then you're not going to be as expensive as that. But if we're talking doing reveals and negative details and all sorts of good stuff, then that's when your rates start going up. For standard Otsumogaki, Velvetina on flat wall surfaces, you're between $160 to $200 a square meter is generally where we sit for that. Talking external claddings, you can go anywhere from $160, $150 for masonry application of a render system over a masonry substrate that's already installed, through to sort of $250 to $270 a square meter for our full lightweight concrete supply, install, finish type solutions. And then if you looked at our Extherm Gold, you might be in that sort of $230, $240 a square meter bracket. All right, so depending on the substrate, that's probably the big difference. Is if you're looking, so if you're looking at our integral lightweight concrete, it's a lot heavier. There's a lot more labor involved in installing that. So the rendering and coating systems and flashings don't change, just the substrate. And if you're looking at Extherm Gold, for example, that's fast and easy and lightweight. So you get a significant labor saving in that space, but you also get really good thermal benefits. So it's that trade-off. We do have clients that do our integral lightweight concrete for the downstairs, for impact resistance and acoustics, but upstairs they'll use a lightweight cladding for better thermal performance and things like that, and also to reduce some costs in the build. But aesthetically, you wouldn't know the difference unless you were going to knock on the wall. So
yep. Interesting one from Shannon Cocker. Thanks, Shannon. Working on historic buildings without testing, it's not always obvious if plaster or mortar is lime-based or Portland cement-based. is it beneficial to repair with lime-based even if Portland cement is present? But lime plaster stable over cement, what allows the wall to breathe if lime-based is present? I think you get the gist of that one.
Yeah, I think whatever was applied originally, you'll never get it exactly the same. It depends on, I mean, obviously, I mean, if you ring us up and say, look, I need a clay-based plaster, or I need a lime-based plaster, we can provide you the chemical analysis for those particular products, and they can be ratified. We can even do sampling if it's required. There are the lines that get crossed in terms of historic building repair, particularly when you're talking seismic. If you're talking seismic repair, then you're not going to do a seismic repair just with a lime plaster. You'll need to do it with this other structural system and then go on with your lime plasters. But I'm happy to have a chat with you around some of that remediation work that we've done on projects nationally.
Question from Eva Brown here. What's the expected shrinkage rate of EPS, XPS, and extern products over years as they seem to be exposed / unsealed from the air in the cavity, so it's subject to drying cycle? Does that make sense? I may have read that out incorrectly.
Well, what I think, so once our styrene, it's, for example, our extruded board or our PIR board, even to a degree, the styrene-based systems, they're closed cell styrenes, so they don't actually, and even under pressure, they'll actually float. So I'm just not quite sure, because the XPS and the PIR extruded systems, they're chemically formed. The expanded one essentially uses heat and steam, and that's, we don't see too much issue around that space. I might need to just touch base with you just to understand exactly what the question is. If you're talking solar-driven moisture, vapor coming out of the building, so we might just have to touch base verbally on that one on a phone call.
Yeah, we'll come back direct after the webinar in the next few days, I guess. You've got a long list of other questions to go back to people here on as well, Mike.
It's either a good thing or a bad thing. I'm not sure if I explained myself or I've just generated a whole lot of conversation.
It's a good thing. We've had a good rush of questions come in, so we're not going to get to them all, but I'll ask one or two more. I guess people's got other things to move on to, but pretty interesting one here from Liam Nolan. Are you aware of any plaster coatings that contain asbestos? I guess they're the older versions, or they never contained asbestos.
Oh, I don't know. I think they may well have. I think that some of the earliest intermescent coatings certainly would have, in terms of, but certainly not in, I mean, I've been around for a while, but not quite that long. No, there's no asbestos utilised in any of our products, at least anyway. And I'd certainly, I would be making clear if there was, I can't even imagine. I don't even know if you're going to buy asbestos anymore, except for if it's, if it's even an available product these days.
Just one more. There's quite a few here, but just the last one is, how do you deal with cracking and high finishes surfaces? That one's in from Mark Williams.
Cracking and high surface finishes?
And high finish surfaces. High finish
surfaces, externally, internally.
Doesn't ask that there. Just I guess.
What we would say is, I mean, we have, for external, we have requirements, and equally internal, we have requirements for control joint locations. So generally the wall's broken down in certain areas to allow for any potential movement. If the wall moves in an area that, for whatever reason, post-construction movement was unforeseen, depending on the aesthetics, because if it's just a surface crack, it more than likely is aesthetic. But if you're unhappy with that, or the client was unhappy with that, we would generally resurface that area, that particular area, from the corner to corner. We would potentially even install a retrospective control joint, because the building's shown us where it wants to move. Internally, exactly the same process. All right, we're a little bit more fortunate these days in that the framing is generally a lot drier than it has been historically. So we don't tend to have the same sort of movement that we would tend to expect. But there's no 1000% science that says the wall's going to move here or it's going to move there. We're very much experiential in that space to say at 8 metre vertical centres, you'll have a vertical control joint. And at 5.7 horizontally, you'll have a control joint. At narrow widths on bifold doors, you'll have a control joint. Just to allow for some of those movement points. But generally speaking, particularly if it's internal, we would actually resurface that wall to actually bring it back up to a standard that was acceptable for the client.
Very good. Well, thanks, Mike. That does bring us to an end for today. Thanks for your time. It was a super interesting topic there, and we've got lots of good questions that we haven't been able to get to today, so we'll certainly come back to people in the next few days with the answers on those. Contact info for Resene Construction Systems will be in the follow-up email tomorrow as well. So if anyone's got any questions, you can go direct to the guys at Resene Construction Systems, or fire your questions through to webinar@Resene, and we'll answer them, or we'll forward them on. So thanks to those that have tuned in today. Thanks for staying with us on the Q&A there, and we'll leave you now, so stay safe, and we will see you at the next webinar. Bye for now.
Thanks.